Hello everyone, my name is Hildobby, and I'll be hosting a panel today on how large language models and crypto data can tie into one another, whether at the implementation level, surfacing data, and all this. And yeah, I'll have my three guests here. First, I'll let each of them introduce themselves before we get into the topic, as well as maybe a quick few lines on what they do in their company and how they leverage large language models. And then we can dive into some questions. So, yeah.
Hi, so my name, is this working? Can you hear me? Okay, there we go. So my name is Richard Blythman. My background's in AI. I worked as a machine learning engineer in big tech for a few years, what we would now call generative AI. Then I fell down the crypto rabbit hole about 3 years ago, started exploring the intersection of Web3 and AI, and kind of realized that there wasn't much going on. So had to decide whether, my thesis that the intersection was interesting was wrong, or if it was just early. Decided it was the latter and just kept working, and now it seems like it's gaining a little bit of traction more and more. I've always been really interested in data infrastructure in Web3 and how we can build AI infrastructure on top of it.
Cool. Yeah, so I am Anirudh, or Ani, whatever you can pronounce easier. So I'm a senior research scientist at Semiotic Lab. So in terms of what am I doing, I think Sam showed you the agency demo a few minutes ago. So working on that. My background is primarily, I started out in computer vision as well, but I moved more towards reinforcement learning, specifically multi-agent reinforcement learning applications, which I think ties in really well with a lot of the problems that people are seeing nowadays with LLMs. You see, LLMs being trained using reinforcement learning nowadays. You also see things like within the Web3 space, within MEV and within DeFi, you hear about intents all the time. That also ties in quite nicely with my background. So just, yeah, excited to be here up with these guys.
Right. Hi, I'm Ivan, a co-founder of DataOS. My background is mathematics and computer science. I have built a traditional financial infrastructure company before and a centralized crypto exchange in Germany. And now we are using large language model as kind of a core infrastructure to build apps on the fly.
Awesome. All right, thanks everyone. So first I would like to dive into the caveats of large language models that are currently popular, in that they are very centralized in their current form. And maybe one of crypto's fortes is decentralization. So maybe how do you think decentralization, crypto as a whole, could help large language models in their implementation or in other ways?
Yeah, sure. So I think, we've all seen, what OpenAI is building. I don't know if anyone watched the OpenAI Dev Day just last week, but they kind of announced something like an app store, right? So OpenAI are building this, this AI cloud. It's closed, it's proprietary. They have full control over it, full governance, and I think there's like a lot of dangerous things there. Like, for example, people may have used ChatGPT at the moment and asked a certain question, and it says, oh, I can't answer that. Who gets to decide what is answerable and what is not? I think it's really important to have some sort of, decentralization in there in terms of governance.
Yeah, from my perspective, I'm primarily, my background is in research. So in that context, I think, one of the things that we talk about is that we like models to be able to be reproducible. We like, when people publish papers, we like to be able to actually check that their results match what they say they should be. We like, especially when people tend to be open and share all sort of the secret sauce behind what they're doing, just in terms of, what we want ultimately is for the entire field to advance as a whole, especially in research. So in that context, when people keep things in closed source systems and stuff like that, it's not particularly great in that sense. But at the same time, I think as long as, ultimately to me, it's about advancing the field, it's about continuing to share things with each other and just be honest. So, and I think conferences are pretty good about this now. A lot of conferences, AI conferences now have started to put in requirements that you must open source your code for any paper that you submit. So steps like that, I think, are helping in this direction, but definitely there's still a lot that we could do.
Yeah, I mean, I think it's important. I agree with what both of you have said, guys. I think it's important to divide it. If we look at large language models, they're completely distinct from crypto, right? They're almost nothing to do with it. But there are kind of three core elements that were slightly mentioned here that define a large language model. It's data, it's compute, and how you do the compute, right, behind. So if we look at all three of them, how we do the compute, we already have GitHub for that, right? Sharing our research. Some doing it, some not. It will be great if we can incentivize it to do it more. Compute is, I think, it's the furthest away, and I can elaborate about it in a second. I think the low-hanging fruit for us is data. Why compute the furthest away? Computing large language models, training them, it's base mathematics, it's inherently a sequential task. So if we decentralize it, we win on things like governance or data attribution, but we definitely not win on cost or efficiency. So we have to be aware of that. But data, it's something which is, we not necessarily have access to the same data that bigger enterprises have, like OpenAI. And I think this is something where crypto could really flip the switch.
Okay, so you touched on an important point, which is definitely the data aspect. And one big thing that has been an overhanging discussion around large language models is licensing and data in general and how that works. So do you have some thoughts on how maybe in the future we could have crypto and be leverage this whole system in order to have better licensing and hopefully fix these current issues?
Should we go the same way? Or
you take it as you want.
Do you want to start? Or?
Yeah, sure. Well, the nature of a large language model, if it's trained, right, it's just a graph with weights and nodes. So you cannot really license something there. You cannot attribute, so if you get an output from ChatGPT using just the base model, no external data, no live data, you cannot really attribute what data has been used, and you cannot say like, hey, that has been licensed or not. You can do it before you train the model, or you can do it if you use embeddings. Embeddings is if you have live data and you inject it into the context, into your base model. An example that I always like to give is, if your model speaks English and you want to teach it French, you give it a lot of French data and you train, and every time it gives you an English input, you say bad, and then it retrains again. You give it new entropy, it retrains again until it speaks French. If you don't want to do it and want to do it live, you give ChatGPT a PDF with the description of the French grammar. Your model will never be able to speak French, but it will be able to verify in French text or write a Twitter thread why French is a cool language. And if you use embeddings, you can do data attribution, and then you can have some sort of licensing. If you train this data, it's basically a black box. So that have to happen before. So I'm curious what you guys thinking, how that could work, how we could empower people to license the data and understand that they can extract value from it by providing it to large language models.
Yeah, so one thing I will start by saying is just that, so if you ever get a chance to go to an AI conference, which I definitely encourage, one thing that you'll see a lot of is people that have a lot of expertise, very, very intelligent people get up on the stage, and then someone asks them a question, they're just like, yeah, it's slightly out of my domain, there's probably someone who knows more, you shouldn't ask me. So I'm probably going to do something very similar here, right? I'm an AI specialist, I'm not a lawyer, I don't know much about licensing. I think it's a very important conversation to have. I think it's important to understand how we can use this data. And again, for me, there are two aspects of it, right? I think the research generally should remain open. I think that should be under permissive licenses wherever possible. But I also understand the need to be able to monetize things, to put it under less permissive licenses if need be.
Incentivize people, right?
Yeah.
If the available data is over, how do we get data from the silos back to the people, and people feel encouraged actually to produce new valuable data?
Right.
Incentivization.
Right. Yeah, and this is, like I said, it's a great question. It's just not one I'm equipped to really answer.
Yeah, first of all, I totally agree with Ivan on like using these embeddings. What's really interesting about this like next generation of AI is that it's all based around inference, or at least more of it is based around inference. It used to be if you had data and you wanted to personalize a model, you would have to update the weights and train it, right? But then it turned out that as we train models above a certain size, this capability emerges called in-context learning, which is basically a new way of passing data into these models to personalize them. So rather than passing data in and updating the weights, you can just pass the data in the prompt, and it kind of personalizes on the fly. It requires much less data, and so you can build like personalized models really quickly using libraries like LangChain, just on top of something pre-trained like GPT or some sort of open source model, right? And unlike training, where the data that you pass in, it's kind of like a black box, right? And you don't know which piece of data was used to generate an output. That's not the case with in-context learning. And you can actually, determine which piece of data was used to generate a certain output, which is super exciting. So people are starting to think about language models not as like a database anymore that stores all of the knowledge in them. They're starting to think of them more as like reasoning engines, which can like reason over the data that's passed in. And so rather than storing the data in the weights of the model itself, which is super inefficient, people are starting to store the data outside the model. And so you can train an LLM to actually retrieve from an external database, right? And what is blockchain but a kind of database, right? So there's some really interesting intersections there, I think, that will help with attribution, right? Before it was completely intractable to determine which data generated which output. Now it is tractable, and then the question becomes like, what sort of attribution framework can we put on top? Like, do we mint NFTs for different assets and rewards people who contribute data to improve a model? I think there's like a bunch of really interesting mechanisms that we can try there, and that kind of ties in with licensing as well. I think a lot of people are experimenting kind of at the intersection of NFTs and licensing. I think before we had this new technology of NFTs and that sort of thing, there was really only like two ways of doing it. It was like fully open source or fully like proprietary intellectual property. And I think it's like more of a spectrum, and there's like a bunch of really interesting things that we can try in the middle. I know some people playing around with like remix protocol with data, which is like a way of allowing people to build on top, but having some sort of reward mechanism that feeds back to the original creator. So I think there's just like a huge amount of experimentation that we can do in that area, and it hasn't even really started yet.
So maybe one follow-up question I have to that is, so in general I agree in terms of like, okay, I think vector DBs are the popular one. There are also knowledge graphs. There are a lot of other ways that you can store data outside of an LLM and retrieve that data, basically condition the LLM in ways other than with the prompt itself. However, there's still, especially if you're using like let's say a chat GPT or something, you're using something commercial. So if the model fails at that point, does it get attributed to your data source? Are you saying that it's my conditioning that's the problem, or are you saying that no, it's the model that was trained by someone else, or I'm just using Llama off the shelf and I'm conditioning it on my data? So I don't really, I guess that's something that I'm still missing.
Yeah, that's like a tough part as well, which is like an LLM can't distinguish between like trustworthy data or non-trustworthy data, right? If let's say we create this shared database of all of the different knowledge sources that are going to be used to drive an LLM, how do we allow people to add knowledge sources into that repository? I think we need some sort of like reputation system on top, right? So like we already kind of have this when we're training LLMs. So like one of the most popular, one of the most effective data sources for GPT-3 was Reddit, and how they actually chose which data to use to train GPT-3 was based on like upvotes and karma, right? So they basically scraped all of Reddit and said, only use posts that have greater than 3 karma or something like that. And I think we can have something similar with this like shared knowledge base that everyone can add to, and then we can have some sort of reputation system, like maybe on chain, where people can like upvote different data that can be used to drive that LLM.
Right, so this sort of goes back to a similar discussion like with RLHF, right? With RLHF, like the thumbs up and thumbs down that you see when you use ChatGPT, whenever you give a thumbs up, you're basically giving feedback to OpenAI that, hey, I like what this thing outputted. I guess the problem with something like that, it depends on how you'd implement the reputation system, I guess, but the problem with something like that would be, what we see with ChatGPT is it can't solve quantum physics problems for you. Why? Because it's good at making stuff up that looks like it solved a quantum physics problem, because that's what people vote up on. It's not actually solving quantum physics problems. And so you get into these situations where like purely relying on this external data source without fine-tuning doesn't seem to be enough. Unless you have some way to actually verify that, I mean, it just goes back to like the classic garbage in, garbage out, right, at the end of the day. So yeah, I think there's some like interesting thing that it's still like an open area within the literature, to be clear, of like how these two pieces, this external data store, which is more like a conditional, it's just turning it into a conditional probability, interacts with the model itself. And yeah, so it's just something I'm still unclear about.
Yeah, it's an interesting question. Like, you know, GPT, because it was trained on text data on the internet, it can't, you know, do some of the maths problems that you're talking about and stuff. I think like if we crowdsource data in a decentralized way, you could actually have these communities that maybe one community are experts in maths and formal verification or something, and another one are experts in, you know, some other area of knowledge. And I think by, you know, crowdsourcing this data, you know, having some sort of decentralized reputation system, I actually think we can like do better than the centralized data collectors can do.
Sure.
Talking about reputation systems, you could, you know, train LLM to rate content as well, and to remove human out of the equation. It's also an interesting idea. Just to finish up on the licensing part, I think it's the traditional licensing is, you know, we always think about like a piece of paper that says that, you know, you own something. At our ecosystem, we using this concept called UDL. It's Universal Data License, which incorporates license and enforcement of this license in a piece of data. So it's a become first-class citizen. So if you want to compute on it, you kind of have to fulfill certain properties. And maybe that is a way to answer this question: how we license data pre-training to get the people rewarded who have submitted it in the first place.
So you guys touched on reputation, which I think is a very interesting topic and still one that needs to be solved in the LLM world. And so I'm a data scientist, and I do a lot of manual querying and trying to understand the blockchain myself. And I'm still very skeptical of using AI because of its sometimes inaccuracies, and over-reliance on it can be very dangerous, I think. So let's say this problem of reputation is solved. How do you see a future where, how can analysts benefit from this LLM technology in the future? How would our workflow change, and how would it be that we adapt in that new paradigm?
Yeah, I think like, I think first of all, Sam gave a great example of like a natural language interface to data, like in this case, tabular data. I think that's definitely going to be something that will be used in future. But not just like a natural language interface to, you know, SQL queries or something like that, which you can do at the moment. But I'm sure some of you have played around with OpenAI Code Interpreter as well, where you can, you know, upload some sort of data and you can ask it questions, and not only does it like kind of retrieve data and generate a natural language output, but it can actually, you know, write code to transform that data. And so like, I think that's really where data analysis is going to go. Like when I was working as a researcher, if I could just, you know, upload that data and start, you know, talking to it and generating new figures much easier, I think it's really going to streamline a bunch of that stuff, and it's going to be a human working together with AI. The AI will do all the annoying stuff like formatting figures, and I think that's going to be a pattern that we see much more.
Yeah, I definitely agree. I think we see this a little bit. I think we've seen a desire for this already, right? I think one thing we broadly accept within the Web3 space is that one of the barriers to entry really has been UX, right? And I think this is really something that LLMs, in general, providing this natural language interface could help with. Even expanding beyond the data science applications, right? Bringing in people, other people. And one of the things that you're talking about there, in terms of like this full pipeline where a data scientist could just go back and forth with an LLM talking in English, or not even in English, in whatever language is most comfortable for them. Maybe it's pseudocode, right? It doesn't really matter. But going through that workflow, getting back some results, I think it drives us towards this direction of intents within the DeFi space, within the MEV space. But I don't think intents necessarily has to be limited to those two spaces. It's just where they're traditionally talked about. And I think in an interesting way, LLMs start to enable that. There are some major challenges before we can really get there. But I think driving in that direction as a community, again, sort of helps us out with this UX problem that we seem to have.
I might take a slightly contrarian take here. I don't think LLMs are a tremendous value add to understand blockchain data. Blockchain data is structured, it's immutable, and as Richard stated, it's probabilistic, so it's just a function of effort for me to implement something that understands this data precisely. But I see a value add of, if that understanding is achieved, to be able to experiment, to act on it, to execute on it, create queries, make the development and the interaction with it much easier.
Right. Yes, I think we're on the same page. Intents. Right. So like it's so in the RL or in general control theory, what people talk about is sense, think, act. Right. So you're sensing something. In this case, you'd be sensing the data, which could be done in again, like you said, blockchain is very structured data. This doesn't have to be LLM related at all. But then think and act are sort of the difficult parts of that chain, right? And so this is where LLM and more broadly, solvers, other tools that we have at our disposal really come in handy. But I think LLMs being the interface to all of those tools, to where users don't have to think about, oh, I should now use this solver, and I need to pull this algorithm, and I need to know about this, machine learning tool to use. The LLM can abstract a lot of that mental load away.
Yeah. Well, I'm using it every day. I don't write code on LLM anymore. Not a single day, I think, in the last couple of months.
The action stuff is really interesting, I think. So not even just talking to AI to help you understand data, but as you browse your computer, browse the web. There's a bunch of projects that are working on, a natural language interface for, you could say, book me a trip on Expedia or something, and it can navigate to that page and do it. I think you can do it on OpenAI now as well. Mm-hmm. But yeah, you can imagine something similar made for Web3, right? Because browsing Web3 is much more difficult than browsing Web2. And why do I have to sign 4 transactions myself? Can I get my personal agent to maybe only surface the most important ones or explain them to me, and then do most of the work itself?
Yeah. So I think you touched on the point, which is data in Web3 is complex and needs necessary understanding of that maybe a few people have, but not everyone. And so how can actually the wider masses who are curious about blockchain data can leverage AI and models to, how could these masses use AI models in order to better understand crypto data and maybe leverage what they need rather than relying on maybe analysts? How would that work? What do you see in the future play out? Do you have a tool in mind that you think you'd have access to and could be, is it just NLP that you ask questions to, natural, a conventional AI, or is it something more? What is the future and vision there?
Yeah, I think we touched on some of them. And another one that I would mention is you could have multi-agent systems of data processors who are constantly acting as research scientists and trying to process data in various ways. For example, you could have, I'll give an example with blog posts, for example, but it might be similar for tabular data. But for a blog post, that's raw text. At the moment, that gets used with retrieval augmented generation, with embeddings and stuff. But there's a bunch of basic data transformations that you can apply on that blog post that are useful. For example, maybe I want to generate a summary of it to use for some sort of retrieval. Or maybe I want to generate questions and answers about it. Or maybe I want to start to turn it into a knowledge graph. And so we could basically have these LLMs, these agents in the background, working with blockchain data, processing it, turning it into knowledge or more useful forms of information, and even comparing different types of data and trying to find similarities or interesting pieces of information. So yeah, that's another thing that I think, apart from the natural language interface that we mentioned before.
Yeah, so to me, I really only think of LLMs as helping out with the interface. Underneath the surface, I think we've touched on already. They're somewhat unreliable, even up to the last papers that I've read, which are very recent as of this week. Conditioning on external data sources still is not a perfect science. There's still a lot of ways in which it could still, these LLMs can still just end up doing the wrong thing or what you don't expect. On the other hand, there are a lot of very reliable AI techniques, right? There are AI techniques, for example, I'm not saying obviously we would use them in crypto, but just to sort of demonstrate that these are reliable. I mean, they've been in your washing machines and your dishwashers and stuff since like 1980. They just work and you don't need to know about them. I think it's very much the same with this, right? We would have this LLM interface. The LLM can be a bit whimsical, but underneath you have these sort of more traditional AI-based tools or even non-AI-based tools, optimization-based tools, solvers, whatever they are, that you can just try to leverage. And so the stochastic, the unpredictable nature of the LLM matters a lot less at that point, because you can just get the LLM to give some basic instructions and then pass those down to things that have a much better idea about what they're going to do.
Yeah, I agree on the point. I think everything was said. I want to emphasize this composability between heuristics, classifications that we had for years in the past, and large language models as kind of the ultimate stack.
Okay, so I'm blanking out. Yes, so I wanted to touch on something which is early on the implementation side. There's stuff to be leveraged from the crypto community and crypto developers, and then there's a lot of AI research is somewhat segmented in a different sector. How could the two work together in order to maybe implement the best implementation of whether it's an LLM or crypto and both tie in together? How could these two sectors collaborate effectively?
I think there's just one word for it: incentives. We need to build the right incentives for it. I mean, collaboration techniques is not something new, right? People can collaborate on things that interest them, and they're doing it already. But we need to create the right incentives. And especially, compared to an open source project where you write a JavaScript library, where someone can invest 20 minutes, to implement a method, and you're all good and happy. Or if you think about Linux, right? A couple of smart people got together and, they put time in and built this amazing operating system. But if you think about LLMs, that's a lot of money involved and a lot of actual hardware involved. So we really need to fix incentive if you want to scale this concept of collaboration.
Yeah, I want to build on top of that. I in general agree. I think we also have a lot of shared values between the Web3 community and the research community more broadly. I think one thing that could, so a bit of a story in terms of how I got into this space. I got into this space just because in reinforcement learning, there's a problem called the sim to real gap, the simulation to reality gap. And it's not a problem I'm particularly interested in, personally. I'm interested in other parts of reinforcement learning. But the gap is basically when I train an agent in simulation, it doesn't necessarily translate well to reality. There are various factors, like the mass of the system that I'm training is off by 0.1%, and all of a sudden it's a massive deal. It's just not a problem on the blockchain. The simulation is reality. And so things like that, where we have areas where researchers who have interests that align with ours already, but just don't really know about the space, because I don't think we have great participation at these conferences, at these events where these people are showing up. I think getting more involved in those spaces would really help just demonstrate to people that, here's the stuff that you can play around with as well.
Yeah, it's really tough. AI developers and crypto developers, I think there is a lot of overlap, but maybe they don't realize that there's overlap. And that's like, when I came into the space, it was one of my observations, which is like there's no one from the AI space in crypto, or very few at least. And I was working in the Ocean Protocol ecosystem at that time and started trying to onboard people in AI, and it was really, really tough. And so yeah, I think it probably hasn't come that far in the last like 2 or 3 years as well, I would say. I would have expected more people from AI to come in. Like we've been trying to bring them together. Like we had a hackathon in Paris for decentralized AI, and Hugging Face were sponsors, and projects like Llama Index, who are creating like the libraries on top of embeddings and stuff like that. But then most of the hackers there were from the crypto space, so haven't managed to get like AI hackers and that sort of thing. But I think like events like that, really making a focused effort to bring the AI and crypto community together is probably the best thing to do. Like more crypto people need to go to San Francisco and like spread the good word. Yeah, just more events focused on bringing AI and crypto together, because I think events like this are great, like Datapalooza. It's great to have stuff like this, but it's very much focused on crypto, I would say. And so how do we bring more AI developers in? How do we not mention tokens as often? Keep our mouth shut on certain things that NFTs maybe we shouldn't mention too much. Yeah, it's really tough, and I haven't seen a lot of effort in it, and I think it's going to take like a lot of focused effort to bring the spaces together.
I think a good start will be if all of us are adding EAC to our Twitter handle.
Exactly, yeah. I've actually been following EAC. For anyone who doesn't know, it's effective accelerationism. It's kind of like a pushback against like AI safety debate, which is, some people would say, gone a bit far in terms of its doomsday scenarios and that sort of thing. And this new movement, EAC, came out from San Francisco, and I've been like following it, and there's so many similarities with Web3 values, right? It's like, we don't want these centralized AI companies imposing safety on us and telling us what we can and can't discuss, right? So I've started trying to like reach out to people in the EAC space. I think even Balaji tweeted about, different types of EAC. There's like centralized EAC and decentralized EAC, and people are starting to explore overlaps in values and that sort of thing. So I think that's a really good path to go down to.
An excellent point, yeah. Overlapping, that's a very good point.
Exactly, yeah. There's actually a project in San Francisco I just came across like yesterday called like Hyperspace, and they're working on building this index over vector embeddings, and they're using blockchain as well, right? And so like just when you start talking about indexing and decentralized and all these sorts of things, like it sounds like a very similar infrastructure that is needed compared to like what we're talking about building in Web3. So yeah, I think just the networks just don't overlap at all, and how do we get more people to know each other in those spaces and get people talking? That's like the hard part.
Okay, so more events, I think, is the takeaway here. And yeah, I was curious, now that we've touched on several things around AI, are there any improvements that you'd like to see, or different evolutions of current AI models that we haven't touched on, that you're excited about, that could touch on crypto data?
Yeah, so I'm going to restrict the question to talk about LLMs instead of all of AI, because we'll be here all night, if not all week. Yeah, so I think there's a lot. I think one of the main things we've already touched upon is these external data stores conditioning on these things a bit better, making the LLMs into things that are a lot more reliable than they currently are. I think that's going to be a big advancement. I think another thing is going to be the size of these models shrinking, the cost of running one of these models shrinking, the cost of fine-tuning continuing to shrink. It's going to enable a lot more people within the community to be able to do stuff with these. Because right now, I mean, you need a massive GPU cluster to be able to do anything, and no one has the money for that unless you're a big player already, or if you're a university and you get certain, you have certain collaborations or partnerships. In addition to that, I think there are a lot of interesting applications. So LLMs, for those of you who don't know, are built on top of units called transformers. And recently, I think transformers have already been popular since 2017, since they came out. But you see a lot more interest in developing new transformer technologies to provide extra functionality on top of what already exists in LLM space. So for example, being able to, so one thing LLMs are particularly bad at is saying when they don't know something. That they'd rather just make up an answer and pretend they know it than tell you that they don't know it. So there have been interesting advancements in sort of Bayesian transformers and things like that, where now you're relying on sort of a separate flow through the model that's giving you a numerical value that gives you some sort of confidence score, some sort of appreciation for what the LLM is saying and whether you should actually believe it and follow up on it, do some later action on it or not. So yeah, I think there are a lot of things I'm excited in, but I'm interested to hear what you guys are.
Yeah, I agree with what you already mentioned. I think the topic of synthetic generated data is quite interesting. There have been a couple of papers. I think one is called Textbooks is What You Need. Is the team is proving that with a bunch of synthetically generated data, they outperform the best model in the space right now on certain topics. And what they do is they have some set of properties how the data should look like. It should be atomic. It should not have noise. It should, have a clear explanation what it does and how it does. And if you think about code, you can generate something quite well. Let's think about Fibonacci, and you can say, hey, give me a iterative implementation, a tail recursive one with a while loop, so you could generate multiple of examples, and it goes on. And you can use the synthetically generated data actually to feed your model.
Yeah, those are great ones. And yeah, you've kind of mentioned everything on models. I guess like zooming out a bit, like what really excites me in the AI space at the moment is that everything used to be about the models and training the models and that sort of thing. What's cool about this next generation of AI is that the model is just one component of a larger system that includes many other components. For example, people are giving LLMs memory now in an external database, or people are using external knowledge databases, or people are building, repositories of like functions or skills and these sorts of things. And all of these different components work together to create an AI system rather than just a model, right? And OpenAI is building a new platform around these systems, and they're trying to like vertically integrate us. They're going to make it proprietary, right? So OpenAI will provide the vector database. They'll provide, the LLM. They'll provide the memory store. They'll provide all of the apps on top of the LLM. And so they're kind of like Apple, the Apple Mac OS in this new operating system or platform that's being built. I'd prefer to build the Linux of this platform, and I think that's something that the crypto space can do, right? Which is, rather than having one organization build all of the different components and services for this platform, why don't various companies come together to build different components of that system? And you can already kind of see this the way, the way that like nodes in crypto run. So like, I think how it's going to work is that rather than having this like node just running on AWS or something, it's going to be a node that runs on a local machine, right? And this node is going to be composed of different microservices. So for example, maybe an AI node will run a compute node, and maybe it will run a storage node like IPFS or something. And maybe it will run a graph node for indexing, and maybe it will run some other nodes. And maybe this AI node is actually made up of like 20 different services. And even better, each person who runs that AI node can like customize which services they want to run in that node. So maybe one of them wants to run like a full Ethereum node or something as well. You can basically customize the type of AI node that you run. I think that's what we can do in crypto to build this new platform, is to like take a decentralized microservices approach and be kind of like horizontal rather than vertically integrated. And that's what I hope it all moves towards, but we're a bit behind at the moment. And centralized AI is kind of like moving quickly ahead.
I like the modular kind of LLM part of many blocks, building blocks that you described. Before I open the floor to questions, maybe Ivan or Ani, do you have some thoughts on this that differ from his, or not at all?
No? Good.
No?
Yeah, I agree.
Okay, well, then if anyone has any question, I'd like to open the floor to any questions from the public.
Sam's going.
Oh, yeah.
So, Richard, you just mentioned the fact that the centralized AI is way ahead of decentralized AI. And I think, well, in particular, you had mentioned the blockchain AI efforts. And I think the centralized approach, they got to be ahead because of all of the data and compute and bandwidth requirements for training models. And that is something, training models, I'm curious if training LLMs will, I mean, I think that's why they had the power. They first, it was easier for them to just aggregate all the data. It was easier for them to train because they had all the data aggregated and they'd have to deal with the bandwidth of distributed training. Could we do something, like do we have to, it seems like, do we have to solve a decentralized training problem? Or maybe is our power somewhere else? Like Ani pointed out how, you know, with crypto, the simulation is reality, which is awesome. So we can do stuff that they can't do. And so do we just focus on where we're good at? I'm just curious, like I agree with you that decentralized approaches are just, centralized AI is just way ahead of what we're doing.
Yeah, I think my approach, I think the training problem is like probably the toughest one. Like how do we do all stages of the pipeline in a decentralized way? I think that's a really massive problem. I think like where I would start is on inference. So luckily enough, we have you know, Facebook who have, you know, done the hard part and trained this model and not open source it the full way, but at least we have access to the model weights, right? So I think that's like the lowest hanging fruit is like solving the inference problem first. And then we can, you know, once we make progress there, we can kind of like work our way back to training, I think. And then by the time we do get back to training, there are a bunch of advantages that we have in Web3. Like we have way more power to like crowdsource data and label data. I think we can like leverage that to produce better models than what, you know, centralized producers can create. So I think there are advantages. It's just that there's so much to solve. And I would tackle the inference problem before the training one, which is like super hard.
I can see that at some point of time we will have very well trained base model, open source that we can use, and then I could imagine a future where certain parties come together, collect data, and fine-tune this model for a particular domain-specific use case very deep, and we will have a set of models that are very good in something, and a routing functionality to basically compose the answers to a unified output. I guess there are rumors that ChatGPT also, OpenAI, also internally using a couple of models, and then a model that routes the request and composes the input together. I think it's a likely scenario that we could start with that.
Yeah, I mean, I think the other option is just to wait a bit longer, because right now it's a hard problem. LLMs are massive. It's a massive undertaking to handle this. But we already see there's a lot of efforts being invested, a lot of money being invested, time being invested into shrinking them, making them easier to handle for individuals. And so another way to make this easier, in addition to starting with the easier problem of inference, is to just wait. Let the research community do its job and make our jobs easier before we really try to tackle the hard problem.
And again, the way to shrink models, it's highly specific data, no noise. And this is like a linear correlation with the better data you have, then smaller and more precise can be a model.
Yeah. So there are also, so definitely garbage in, garbage out, right?
Yeah.
That's absolutely always true. But there's also been a lot of work that people have done. So data programming is, for example, a popular technique where you can have like very poorly labeled data. And the reason these have been developed essentially is because a lot of AI models now have performance better than humans and performance better in teams of humans, right? So what sort of happens once you can't rely on the labels that humans are giving you anymore? So people have started to come up with techniques, it's been since like 2014, where people have come up with techniques to really handle this case where the data is very, very poorly labeled. So it helps, absolutely, but I don't think it's like a blocking condition. It's a nice to have, not a must have for me.
I don't speak about labeling the data. I mean just presenting data in a certain form that does not have any noise. Right? For example, it's either you give it open source implementation of a JavaScript library, or you give it a set of methods that are well documented and cleanly written. And, so if we take two models that have been just trained for programming with kind of textbook grade quality data, it will probably outperform the ones that would be trained with waste amount of code, but some of it is not clean.
Yeah, so it definitely depends on the type of noise, but in most situations, they turn out to be the same thing. Like you can put the noise into the data itself, or you can put the noise on the label, but it turns out to be an equivalent problem. There are certain types of noise for which that's definitely not true, and those are much harder problems that people are working on, but yeah.
I think there's like a bunch of simple problems we can solve on the way to like the harder ones. And like I even see it in the EAC community, they're talking about like just making sure model weights are available and not censored and that sort of thing. And there's people like rebuilding libtorrent from scratch and stuff. And I'm like, we've already built that in Web3, right? We've like, you know, IPFS and like all of these decentralized, you know, file sharing and storage solutions and stuff. So I feel like, yeah, maybe like coming up with a roadmap of problems that we can solve using Web3, where at the very far end is like the you know, data for training LLMs, and then really simple stuff like just sharing model weights outside of like centralized cloud and stuff. So yeah, there's lots of problems to solve.
Yeah, I think data engineering is also an underrated problem, and yeah, there's so much things that you actually need to do. I have an example of a company I've been working on, and they generate voices based on the description, and you can say, hey, give me a middle-aged British male working in the finance sector. And so they use embeddings for that. And to do it quite efficiently, they need pre-label the data quite extensively and do kind of weighted querying on the data. Because if you generate a voice, gender is the kind of the highest indicator, but then you go with age, and then you add accent on top. And to achieve that, you need a lot of tooling and data engineering. So we really rely on the good people from the open source community to build those tools for us to be able to achieve better state of things.
Okay, we're a bit over time. Do we have time for one more question, maybe, if there's one? Does anyone have a question? Okay, otherwise, I think we'll wrap it up here. I'd like to thank my three panelists. Thank you for all this, and yeah, it was a great panel.
Thanks, guys.